I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the viewers and subscribers for watching my videos and providing very helpful suggestions. Based on their request, we upload videos consistently. Almost every day, we upload new videos. Now we have crossed 20,000 videos on our channel. All are free for all our viewers. The question here, which we are going to discuss, is from one of our subscribers. She wants to understand how do we sketch the graph of derivative when the graph of the function is given to us. Now this is one of the first steps in curve sketchings for calculus. A visual look and proper understanding of derivatives can help you make very accurate graphs of derivatives. We are going to learn all the strategies required to do this in this particular video. So the question which I framed here is sketch graph of derivative, explain strategy in details. I really mean it. So we are going to explain the strategy in details. You can always pause the video, answer the question, make an attempt, and then check with your solution.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Now, let's see how do we sketch this graph. First step is understand the graph itself. So what kind of graph do you see? Definitely, it is graph of a polynomial. So let's make a note of this. What is the function we're talking about? So it seems it is a polynomial. Now, what could be the degree of this polynomial? Well, that seems to be degree 3, and then we have got two linear zeros. So we have degree 5. So clearly, when we look at the derivative of this function, we expect a polynomial of degree 4, right? So we need polynomial of degree 4. So quartic polynomial is what we are looking at. So that is the first thing we clearly know that we are looking for, quartic polynomial. Now the next step is to translate turning points into zeros. So this is our first step. We have a clear idea. Next step is identify turning points. Well, here we have one turning point, another one. So these turning points will actually represent a 0, right? So this turning point will be a 0 on the graph of the function, right? So this also will be a 0. So we have identified zeros from turning points. So we're trying to sketch the graph of derivative. Do you see that? That is one thing very clear. You also notice that these turning points we have identified in the function, these are zeros. Is that okay? Now there is a very special point here which is termed as what? This is called saddle point. Now this saddle point is also a very critical point. As you can see, the derivative here is also 0. perfect. So we'll make a 0 here also because this is a saddle point. So identify turning points and you can say saddle point, also known as point of inflection. So this will also turn out to be a 0. So you see we have 3 zeros here as shown. Now one turning point, these two zeros are linear. So we have two zeros which are linear. I'll write 1 here. Plus because this cubic derivative is going to be quadratic, so we have 1 0 whose order is 2. You get the idea. So this saddle point will give me a turning point at that end. You get the idea. So we have fairly good idea of zeros of our derivative, right? That was the difficult part. Simple part is to identify intervals where the graph is increasing or decreasing, right? So let's identify the third thing, which is where is the graph increasing and where is the graph decreasing. Okay, so let's move on to the next page just to help develop this concept. Okay, so we have done already two things, and that is that we now know that this turning point will lead to a 0, that turning point will also lead to a 0, and this is also a 0. Perfect. So we are trying to sketch the graph of the derivative, and now we see that on the right hand side the tangent is positive, correct? So this side the derivative is going to be positive. So from here to here we expect a positive derivative, then it's coming down negative, here also negative, and after this point we expect the derivative to be positive. You get the idea. So it's negative around this point. You see that it's negative around this point, and that happens to be a turning point also. So clearly we do have some connection that our graph of the derivative will turn here, right? And before this it is increasing and then decreasing. You get the idea. It is increasing and then decreasing. So the graph is positive in this portion, right? So if I have positive and 0 going through it, it makes sense that I kind of go like this, right? Somehow connect with this, then we have negative and positive. So we could go like this and kind of like this. Does it make sense to you? So we have a quartic function. Now there is one very important point to consider. So we have already considered increasing and decreasing interval, or the graph which is increasing, right? So, and decreasing. So increasing means positive derivative, right? So increasing means that the derivative is going to be positive, right? And decreasing means that the derivative is going to be negative, as shown here. Now one thing which many students do not really understand is on this graph of the derivative, which is a quartic function, where do I have this local maximum or minimum? In this case it turns out to be a minimum, right? So local minimum, it corresponds to which area? This is what I'm going to highlight here and then sketch the graph. Do you have any idea? Where do you get the local minimum? Now the key is that local minimum corresponds to change of concavity. You see in this particular graph, the portion here is concave down, and then at this point it's concave up. Do you see that? So this point corresponds to local minimum. So let me mark point A, which will correspond to local minimum. And here, do you see this is concave down up to here and then concave up, correct? So change of concavity happens at point A and B, and they will correspond to local minimum, right? So that is how we will sketch the graph, and therefore, as I was saying, our graph will look like this. We did not calculate any values, but approximately that is the graph, correct? Let's do it once again and review what we learned. Step 1 was zeros. For zeros, you can also get the order of zeros. This is order 2, right? Turning point. So that will be a linear 0. This is order 2, a turning point, linear 0. This will be a quadratic 0. On the left side, it is positive. So we are on above this graph. Do you see that? And in between, it is all decreasing, right? And here again, it is above the graph. In between, it is negative. Perfect. So we identified that here we all have positive, then negative, 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 and then it rises once again. So positive. Correct? So after number 1, zeros, we identified increasing and decreasing. Increasing means positive and decreasing means negative. Right. And then we look into concavity. So change of inflection. Correct? So concavity, as you can see, changes where? This portion is concave down, right? And you see, this is concave up, correct? Again, we have concave down and we have concave up. Do you see that? So there are two changes in concavities, and these will correspond to maximum and minimum. Perfect. So that looks for maximum and minimum. So we have our graph now, knowing fully well that this line has the turning point. This is, we know that we are negative on this side. So we can now sketch the graph, correct? Turning at this point, connecting, correct? Turning at this point and then going up. Does it make sense to you? Correct? So that is how you could sketch the graph. Let me do it once again. So we come down, this is all positive, now negative, turning point, correct? This is again a turning point of order 2 this time, and there you go. That becomes the graph of our derivative for the given function in green. Are these steps absolutely clear to you? Perfect. You can always learn from me. Send an email on this given address. Master the understanding of the subject and how we can apply to get excellent marks and do well in all our subjects. So let me summarize and show this in a neatly sketched graph, right? So there you go. So here again, we have seen the derivative of the function, where the function was given in green, correct? As you can very clearly see from the graph, the correspondence. The turning points reflect zeros, correct? This is also a 0 of order 2. It is increasing. This portion is increasing. So here we have positive. Do you see that? This portion is decreasing. And so this portion is negative. You get the idea. And this point corresponds to what? Change of concavity. Perfect. Make sense? If you follow these procedures, you can easily sketch the graph of derivative from the graph of given function. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that will be great. Thanks for your time and all the best.